new floating PV system design from Brazil. A consortium led by Apollo Flutuantes has energized a floating PV system on a lake located in Estancia Jatoba, near Campinas, in the Brazilian state of São Paulo. The system is being operated under the country's distributed generation (DG) scheme and sells excess power to the local grid. The 69 OW bifacial installation is equipped with a tracking system and rotates from east to west following the sun to maximize energy generation. It relies on solar modules provided by A-Solar. From the beginning, A-Solar carried out tests and discovered something that not even we knew, that the floating Apollo technology has an excellent albedo, of at least 17%, the CEO of Apollo, José Alves Teixeira Filho, said. The project also functions as a demonstrator for the standard 7 MW system developed and patented by Apollo, which is 180 meters wide by 280 meters long, with 9,000 bifacial modules. The system weighs approximately 1,200 tons floating, with a further 396 tons submerged for anchorage. It may seem simple, just a buoy, but it's not. This buoy has to last 30 years, said Teixeira Filho, noting that the interdisciplinary nature of the technologies requires the presence of several partners. The idea of the consortium is to offer these units both to hydroelectric plant operators who want to hybridize their assets and to companies in the distributed generation segment. Exclusively for floating photovoltaics, it is allowed to build large plants installed, for example, with 300 megawatts on a lake, electrically sliced into 300 slices of up to 1 megawatt and negotiate this energy as distributed generation, directly with the end customer, which is prohibited for ground installations, he also said. This provides economic gains for floating plants very quickly. Just to give you an idea, a 2 billion Brazilian real project has a payback period of less than 3 years, he added. He refers to Law 14,300, which in Brazil prohibits the division of a generating plant into smaller units to comply with the power limits for microgeneration or distributed mini generation, except for floating plants, as long as each unit observes the maximum installed power limit. Teixeira says that one of the models being studied by hydroelectric plants, in addition to the opportunity for hybridization, is to transfer parts of their reservoirs for exploration by other distributed generation companies, which can benefit from gains in scale and exploit the assets as distributed generation. Thank you for watching and make sure to like, comment, and subscribe for more future videos.